All right, guys. So today we are going to talk about um, natural logarithms, base E and natural logarithms, and what that means. So I've already filled in a few things here for you. So it says, what is E? Well, E is an irrational number with an approximate value of 2.71828, and it keeps going on. So think of pi, something kind of like pi, how it's an irrational number. This is another one of those. Okay, it says E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. Base E exponential functions. An exponential function with base E are called natural base exponential functions. And an example of this is f of x equals e to the power of x. Base E logarithmic functions. A logarithmic function with base E are called natural logarithms. Example, f of x equals log base E of x. This is often abbreviated as f of x equals ln x. Natural logarithm is what ln stands for. Okay, so whenever you're doing that on the calculator, it will be ln is the button that you're going to push. Okay, so first let's talk about converting between forms. So to write each equation in logarithmic form, so we're going to exchange between exponential functions into logarithmic. Okay, well, your rules are the same thing as what we've been doing. So this is your base of this equals that. So it's going to be log base E, excuse me, base E of 24 equals x. Okay, well, log base E is the same thing as saying natural logarithm. Okay, so that's the ln. So it's the same thing as saying ln 24 equals x. Okay, and this right here is the format that you want to get it to. Okay, so number 2. So that's log base E of x equals 9. So natural logarithm of x equals 9. Okay, this one, log base E of 72 equals x plus 5. So natural logarithm of 72 equals x plus 5. Okay, on this one, we're going to write each equation in exponential form. Okay, so this is the same thing as saying log base E of x equals 58, which means that that is going to be e to the power of 58 equals x. Okay, same thing on this one. So e to the power of x equals 6. E to the power of 32 equals x minus 9. Okay, if you wanted to skip that step right there, you can, just like what I just did. Okay, now simplifying with properties. Your properties are the same thing, the same properties that we've already learned, same thing we've already gone over. Okay, addition means actually multiplication. So condense each expression into a single logarithm. So that would be natural log 3 times 16. Well, 3 times 16 is 48, so it's natural log of 48. Okay, same thing on this one right here. So that 2 right there becomes an exponent. Subtraction is division. So that is natural log 63 divided by 3 squared. Well, 3 squared is 9. So this would actually turn into natural log of 7, because 63 divided by 9 is 7. If you wanted to write natural log 63 over 9 like that. Okay, same thing on this one. So the 1/3 becomes an exponent there. The 2 becomes an exponent there. Addition becomes multiplication. So this is natural log 64 to the power of 1/3 times x squared. Okay, well, 64 to the power of 1/3, that's the same thing as saying the cubed root of 64, which is 4. So that is natural log 4 times x squared, which turns into natural log of 4x squared. Okay, this one we're going to expand the logarithm, so we're breaking it apart. Okay, so 5 is multiplied times x, so that means it would have been addition. So natural log of 5 plus natural log of x. Okay, this one, excuse me, this one has, the whole thing has an exponent of 2, so that means that well, there's two different ways you could do this. If you wanted to first just move 2 to the front of all of it, we can do that. And then we have division right here, which means that it was subtraction, and we have a 3 on the A, so that means we have 3 times the natural log of A, and then minus the natural log of B. And that will work right there. Okay. Same thing on this one, that we have the cubed root of the entire thing. Well, that's like saying 1/3 times the whole thing. Okay, and we also have multiplication between m squared and n. So that would be addition, and the 2 goes in front. So we have 2 times the natural log of m, and then plus the natural log of 2. Okay, and so that will work on expansion right there. Okay, all right, so now let's flip over to the other side and let's look at solving equations using this. So it says solve each equation below, check for extraneous solutions. Okay, well, just like what we did with the logarithmic functions, it's still the same rules, where if they're, the logs are on both sides and they have the same base, which they do because the natural log is log base b, or I'm sorry, log of base e, then you're just going to set what's in parentheses equal to each other. So we have 4x minus 27 equals 15 minus 2x. And then you're solving that. So add 2x over, and we have 6x, and add 27 the other way. And we have 42. Divide by 6, and x equals 7. So then we want to see if we have an extraneous solution. So just plug that back in and see what it equals. Well, you plug that in, and it's going to work on both sides because both of these numbers are going to be equal to the same thing. So x equals 7 is correct. Okay, on 14, well, this 2 becomes an exponent on the k, so it's k squared equals 2k plus 15. Okay, well, to solve this, because we have a k squared, we're going to end up having to factor. So we've got to get everything over to the same side. So we have k squared minus 2k minus 15 equals 0. Factoring that, what multiplies to get negative 15 and adds to get negative 2 is negative 5 and 3. So we have k minus 5, k plus 3. And then solve each of them equals 0. So k minus 5 equals 0, turns to k equals 5. K plus 3 equals 0, turns to k equals a negative 3. Okay, plug those in and check. Okay, well, 5, you plug the 5 in there, and we have 5 squared. And then on this one, excuse me, 2 times 5 is 10. 10 plus 15 is 25. 1 5 squared over here is 25. So that will work. Okay, on the other one, we have negative 3. Well, negative 3 squared is positive 9. Over here, we have 2 and negative 3 is negative 6, and negative 6 and 15 is positive 9 as well. So that will work. Actually, let's see. Sorry, I'm just checking to make sure because, and I know, Heather, I know you had a question on one like this on the last homework. And I see why, because I actually said that that would work because when you do k squared, that makes it a positive. But if you were to actually, if you plug that in right here and check it, so you do 2 times the natural log times -3, well, technically you can't take a log of a negative number. So if you plug it in right here, it works, but when you plug it in here, you take the natural log of both of them, it's actually not going to work because you can't do the natural log of that, or you can't take a logarithmic of a negative number. So Heather, on the one, or if anyone did the same thing on the last homework that was kind of like this, I will just count those correct and make sure that let's just make sure that we fix that now. And that's actually my fault. I explained that the wrong way last time. So because you will get an extraneous solution. I'm sorry, I boxed that in, but that's actually not going to work. You will get an extraneous solution because you can't take a natural log of a negative number. So even though this exponent does, when you actually square it, it does become a positive right here. But if you plug that in just like this, you'll actually get an error and it's not gonna work. So that's my fault on the last homework that y'all did over that, but let's fix it going into the next one, okay? So on 15 here, so we have subtraction, which means we're actually dividing this, okay? So that's 72 divided by 4. And over here we have addition, so that's actually multiplying that. So we have 6 times this, so that becomes 6a minus 12. Okay, well, 72 divided by 4 is 18. We want to add 12 over. And A will end up getting 5. Okay, you plug it back in on both sides and it will work. Okay, all right, 16. So we do the exponent right there, and so that becomes m plus 4 squared equals 4. Okay, well, if we square this out, okay, so if you look on your reference sheet, at the very top on your reference sheet, when you do take the first term and square it, that's m squared, and then you multiply these two together, so 4m and then multiply times 2, that becomes 8m, and then you take the last term and square it, and that becomes 16. Okay, this 4 we still need to move over, so that becomes m squared plus 8m plus 12, because you have to subtract the 4 over, so 16 minus 4 is 12. Okay, now can we factor this? Do we have numbers that multiply to get 12 and add to get 8? Yes, we have 6 and 2. So m plus 6 and m plus 2. And that becomes m equals a negative 6 and m equals a negative 2. Okay, so then we want to plug that back in and check. Well, if we plug it in, the negative 6 into this one right here, so we have negative 6 plus 4, that becomes a negative 2, and that's a natural log of a negative number, so the negative 6 is not going to work. Okay, this one, plug in negative 2. Negative 2 plus 4 is a positive 2. That one should work. Okay, so there we go. On 17, okay, well, because we don't have natural log on this side, we have to actually turn this into an exponential format. So this becomes, well, that would have been e to the power of 2 equals 8x, okay? On your calculator, you actually have the e button, so if you want to square, you just do e squared, and that would be about 7.3891 equals 8x. Well, then to solve for x, you just divide both sides by 8. And so that's going to become around 0.9236, something close to that. Okay, on 18, Similar thing here, okay? We have subtraction, which means that we're actually dividing these two right here, but it still is gonna be e to the power of 7 equals, well, we're dividing x by 9. Okay, well, e to the power of 7 is around 1096.6332. Okay, and then to solve for x, we multiply both sides by 9. And so x is going to equal around 9,869.6984. Okay. All right, 19. This time it is in exponential form already. So to solve for this one, we actually want to put it back into logarithmic form. So that would be log base e of 57 equals x, which is actually natural logarithm of, oh, I wrote 75, whoops. Natural logarithm of 57 equals x. And you can actually type natural logarithm of 57 in the calculator, and you will get around 4.0431. Okay, number 20. Okay, excuse me. Well, first you always want to isolate the exponential part of it. So we want to add the 6 over to the other side. So we have e to the power of y plus 3 equals 30. Okay, so then we have, that turns into log base e of 30 equals y plus 3, which is natural logarithm of 30 equals y plus 3. Well, natural logarithm of 30 is around 3.4012. And then to solve for y, you subtract the 3 over, and we have y equals, so 3.4012 minus 3 is about 0.4012. Okay, 21. Well, first we want to get the e by itself, so we're going to divide both sides by 5. So it's e to the power of 4n equals, so 95 divided by 5 is 19. Okay, so then that turns into log base e of 19 equals 4n. So it's natural logarithm of 19 equals 4n. And natural logarithm of 19 is around 2.9444 equals 4n. Divide both sides by 4. And it's going to be about 0.7361. Okay, and then the last one here, first we want to subtract the 3 over. So we have 2e to the power of c minus 9 equals, and then 87 minus 3 is 84. Divide both sides by 2. So we have e to the power of c minus 9 equals 42. Okay, so then that's going to end up turning into natural log of 42 equals c minus 9. Well, natural log of 42 is around 3.7377. And then to get c by itself, add 9 over. And c is going to equal 12.7377. Okay. All right, guys, so just remember, whenever you're checking for extraneous solutions, when you plug it back in, make sure you are checking with the actual logarithm part. Sorry about the confusion before last week. Whenever I answered that question, I was in the grocery store and was just, I don't know, I guess I didn't think about the fact of just actually plugging it into the logarithm part. I looked at the squared part and I was like, oh yeah, that makes sense. And I see why you got that. So let's just fix it from there. Guys, if you don't have a calculator, a graphing calculator at home to be able to do the natural logarithms and the e's, and stuff, just you can always get online and get a graphing calculator. You can go to the TI website, and their calculators are free right now. You should be able to use one of their programs, but there are other programs that you should be able to use that on as well. I think any kind of online graphing calculator should be able to do any of this. Okay, I will be logging on every day this week from 1 to 2 p.m. Actually, going through the rest of the weeks that would, if we're out longer, from 1 to 2 p.m. And I believe our days are on Tuesdays to meet and talk about the work if you have any questions. Okay, hope you all are doing well.